Are we ready to embark on our journey? I promise you it will be more interesting. As always, to gain momentum, we have to go back a little in time, and they will realize that we missed visiting a very important moment. Let's start by remembering Newton in 1687, who demonstrated the movement of celestial bodies with the law of the universal gravitation. This theory was an overwhelming success and was valid for a long time. Now yes, we come to 1905, the year in which the German physicist of Jewish origin, Albert Einstein, wrote a first article called "To Revolutionize the Notion of Space and Time." This work formulated his theory of special relativity, but it was only the beginning. The revolution culminated 10 years later in 1950 with general relativity, which incorporated the fundamental role of gravity. Despite this knowledge, the belief in a static universe was so ingrained that it persisted until the early 20th centuries that even when Einstein formulated his law of general relativity, he was certain that the universe had to be static. That is why he modified his theory to make it possible by introducing into his equations a so-called cosmological constant. Arrived the inevitable moment when in the year 1929, Edwin Hubble, one of the most important American astronomers and cosmologists, famous mainly for having demonstrated the expansion of the universe by measuring the redshift of distant galaxies, and not only that, but he had also determined in 1924 that our galaxy was not the only one, but there were many others, and that the speed of the galaxy is proportional to its distance. This means that the farther away the galaxy is, the higher its speed. Then the universe could not be static as previously thought. To imagine the expansion of the universe, we'll give an example. Imagine inflating a balloon with drawing of points. The more we inflate, is the distance between the points are moving away from each other, and it is not because they move, but it's the space grows between them and makes the distance greater. Or to give another example, imagine a cake ready to bake with strawberries and raisins, and you pass when you put in the oven, the dough grows and will make the strawberries and raisins move away. It is that the mass that expands as the same happens with our universe. Then we wonder, why our galaxy, when expanding, the planets do not move away from each other and we continue to revolve around our sun? The answer is that our gravitational field is larger than holds us together, which our solar system is that it moves all together. We risk the most important thing in this discovery. It makes us turn our thoughts and gazes towards the beginning of the universe. Hubble's observations made it inevitable to suggest that there was a beginning at a time called the Big Bang, because if we look back of the expansion, the universe it makes us see that it once has to be contracted at an infinitesimal small and therefore infinitely dense point. Many of us will have heard of the Big Bang, but do we wonder how it explains the universe began? According to this theory, about 13.8 billion years ago, matter was infinitely small point on a very high density and temperature. A small fraction of a second after the Big Bang, the cosmos went through expansions of ultra-fast inflation, which went from the size of an atom to the size of a grapefruit. The universe has a temperature of 10 billion degrees, and I think with it that we have known our universe, which also includes space and time. After inflation, the universe was like a super hot soup of electrons, quarks, and other particles. As fast as the cosmos cooled, it allowed quarks to come together and form neutrons and protons. In the first 3 minutes, still the universe was too hot to form atoms, charge electrons and protons, prevent light from shining. The universe is a super hot mist. At 3,100 years, the electrons combine with protons and neutrons. They form the atoms, most of them of hydrogen and helium. At last, the light could shine. A million years later, gravity caused hydrogen and helium gas to form giant clouds that could become galaxies. Smaller clumps of gas collapsed to form stars. At 13.7 billion years, nearby galaxies joined gravity. The first stars died and threw heavy elements into space. These would eventually become stars and planets. But who contributed to the Big Bang theory? It was in 1977 when George Lemaitre, a Belgian priest of physics, came to the same conclusion as Friedman and proposed that the universe was expanding, basing his theory using a framework, the general theory of relativity of Einstein, removing its formula of the cosmological constant. Although it did not have so much acceptance by the scientists of the time, he persisted in his studies and relying on Hubble's discoveries. In 1931, he proposed his idea that the entire universe arose from a tiny point, a primordial atom or cosmic egg, that exploded at the time of the creation of the universe. Theory that Hall wanted to recall with the calling of the Big Bang theory. Later, in 1948, a physicist of Russian origin, George Gamow, along with his American collaborators, Ralph Alford and Robert Herman, made the mathematical developments to shape the Big Bang theory into a scientific theory. As we can realize, at this moment, the Big Bang theory is the sum of the contributions of numerous scientists that we have visited, which have served as a basis for a substantial and scientifically verified expansion of the universe. It seems that reach on the Big Bang still has a long way to go. So it's dear time traveling friends, it has a very exciting trip. We approach our times, but this ends here. See you on our next video.